You are watching TFI.
Greetings, salutations, welcome to a very croaky and sick and nasally TFI. It's the winter, it happens. Apologies for the voice. I can't do anything about it, but I need to get this video out. But if you've been anywhere near social media over the last week, you won't have missed the bombardment of messaging from every Autodesk social media account saying that Generative Design in Fusion 360 is free until December 31st. And you might be thinking, I don't know what that is. It sounds good, but I don't know where to start. Well, I'm going to do you a solid, mate. I'm just going to give you a bunch of files, take you through how to set up a Generative Design study, and then you can do it, follow along, and then you've got a month to just mess about with it to your heart's content. Change the loads, change the inputs, and then see what you end up with, and it's all free. Bear in mind though, if you're a student Fusion 360 user, I don't think you get access to Generative Design. This is mostly for the people who have a paid for or a commercial Fusion 360 license, or anyone who has it as part of the collection. So if you use Inventor as part of the product design collection, then you can do this. So you'll have to go away and install it. You'll have to get your Fusion 360 ready. I can't talk you through all that. I'm trying to make this as quick and as to the point as possible without waffling and going off on a tangent. So I'm going to try and keep explanations to a minimal. Just give you the files, show you how to get to them, and then show you how to do it. And then you can fill in the gaps from there. So let's jump on over to Dropbox. In the description of this video, there is a link to a Dropbox folder. It'll take you straight to here where there's a bunch of files. What you want to do is just make sure that all of the files are ticked and then click download. That'll zip them all up, put them into your downloads folder. You can then click this little arrow here and then click show in folder if you're on Chrome or if you're on Edge or whatever. Just go to your downloads folder. Extract this to its own folder or just dump them in wherever folder you want and then open them up and there's all of the files there. So this here is the original wheel. I'll not open it up and show you it, but it's the original BMW wheel that I created a tutorial for in Fusion and Inventor. And that's the starting point of the original wheel. And then there's a couple of pictures here. So the image for the center cap. There's an M badge on the BMW wheel. There's a sidewall bump map here, along with two files that we need for Fusion 360. Right, so hop on over to Fusion 360, and then we need to set up a project. So I'm going to create a new project, and I'm going to call this Generative Design YouTube tutorial. And that's going to be a brand new, you don't have to create a new project, you can use whatever project you've got, but double click into that, and then we're going to go to File, Open from my computer, browse to the Downloads folder, go into the Fusion 360 folder that I've given you, and then double click BMW Wheel Tutorial.f3d. So this is a Fusion 360 file that I've pre-worked on. I've set up the entire thing for you except the study, which we need to put in the input parameters, but all of the editing's been done in here. I'll very, very quickly take you through what I've done just so you can understand how things got to where they are. So this is the original wheel, but what I've done is I've extruded cut out all of the spokes because that's where I want Generative Design to fill in. The way Generative Design works, very, very briefly, is you tell it to start from some material and then give it some input parameters. You want to minimize the mass, maximize the stiffness of the part, and then it will sort of organically grow material out between the regions that you've given it, and then it gives you this fancy shape which conforms to your design parameters. It conforms to the structural properties that you've told it to. So what we're going to do once that's open is go to this tab at the top and then select Generative Design, and then just shut down this panel on the left hand side because we don't need that anymore. So you've got Study 1 over on the left hand side, and we've also got this button up here called Edit Model. Give that a click and I'll take you through what I've done. I've split the wheel into 1/5 so then we can pattern the generative result once it's finished. And then along the bottom, there's a bunch of features here. And these are just me deleting faces and filling in holes and stuff. Because what I've set up is a bunch of obstacle geometry. Like, for example, the center cap. I've told it, I've turned the body off, but I'll turn that back on. Model components, bodies, full obstacle. So all of this huge, massive solid here, this is me telling the Generative Design module and the algorithm, do not grow material wherever this big massive lump of solid is. So I've exposed a region of the hub here, so it's free to grow material out of these faces and then into this section of the rim. Everywhere else is a no-go area. And that's what all of these features are at the bottom. You can drag the end of part along to see what I've done. Click Finish, Edit Model. And then we can start setting up the study. So we've got study 1 here. And the way you work with generative design is you work from left to right along the top toolbar. So we're going to first go into the drop down underneath study and go to study settings. I'm going to leave the resolution as default, which is sort of just below center between coarse and fine. If you grab this up and move it along to the right, you'll get a super high resolution generative design model created for you, but it can take over 24 hours for the cloud service to create all of the variations. So if you leave it as default, you still get a good result, but it's a lot quicker. So we'll leave that as it is. Right, for the design space, for preserved geometry, we'll want to select the bodies. God, I feel my voice getting really worse there. No, I'm going to crack on. Expand model components in the browser on the left. Expand bodies. And then for the preserve regions, we're going to select the center hub preserve and then the outer rim preserve. So I've named them for you there already. Select OK, and they should turn green. So wherever you can see green material, that's where the generative design algorithm is going to blend new material between. Select this button here for obstacle geometry and then select the full obstacle. Click OK, and that region will turn red. And that's all of the area where it's got to avoid creating material between. Right then, mate, the next bit's a bit fiddly, but we've got to do it. So in bodies, just turn off the obstacle geometry, because this is the material now that we need to work with. And for the design conditions, select structural constraints. Change this over to frictionless. And we're going to create a frictionless constraint on that face, that one, and that one. And then on this one, and then on this one, and then click OK. So that's the constraints created. The next thing we're going to do is go to structural loads, and we're going to simulate the load of the tire bead against the alloy wheel. So this is where the forces from the road are applied to the alloy wheel. It's through the tire, and where the tire makes contact with the alloy is going to be, I'll need to rotate it around a bit further so we can zoom into the face. So it's going to be this face here, and then also on the other side, this face here. And then for the magnitude of the load, it's a funny one, because if you think of the weight of a car, so the BMW M4 is roughly 1,500 kilograms in weight. So if we head on over to, if you open up a calculator, 1,500 kilograms, if you divide that by 4, so that's weight per each wheel, that's 375 kilograms. And because we've got to spread the weight or the forces over 2 faces, we'll divide this by 2 so we know how much load to put on each face, and that's 187 kilograms per face. And then we can convert that over into newtons. So if we go to a newtons to kilograms converter and then type in 187, that's roughly 1,833 newtons per face, but we can round that up to 2,000 newtons per face. So we'll just type in here 2,000 newtons. The direction of the force should be all set up for you. It should be going straight perpendicular down onto the face, and then just click OK on that. And then that's the first load case set up. So you should have force 1 applied against both of those faces. You can see you should have 2 arrows pointing down on both of those faces, and then the constraints. We should have a frictionless constraint in there as well. So we need to apply 4 more loads, but in different load cases. So right click on load case 1 and then clone that load case, and then expand the loads. Right click on force 2, and then you can edit the structural load, or you can click the little pencil. Fusion is really annoying for this. The pencil doesn't appear until you hover over and then go to the right of it. I really don't like bad UI design in my opinion. Never mind. Right, and then what we're going to do is we're just going to rotate the loads. So for the X angle, we're going to type in 90. So we're going to simulate loads coming in from that direction. And click OK. You can activate load case 2, so you can see that is being applied like that. Then we're going to right click and clone load case 2. Activate load case. It's so annoying. Activate load case 3. Go into force 3. And then we're going to flip this by 180. So the load's going that way. Right click on load case 3 again, clone the load case, activate load case 4. Again, just repeat the steps. This time we're going to rotate it on the Y angle by 90. So it's now shooting the loads, oh my God. That in that direction, and then right click, clone the load case again, last one, load case 5, activate that, expand the loads, edit that, and then flip the Y by 180. Okay. Right, so we've got 5 load cases here, which with the forces going in all the directions that a tire can expect, or a wheel can expect forces to be applied. And then just activate load case 1, so that's the default one, and then we'll go back up to the top. Right, activate the objectives, and then we're going to make sure minimize mass is selected, but we're going to lower the safety factor just down to 1. Click OK on that. Go into the manufacturing region, and this is where you tell Generative Design, okay, create some outcomes based on how we're going to manufacture this. Obviously, we're not manufacturing this. We don't have a die casting machines. I don't have a CNC milling machine in my garage either. So it's just purely just for aesthetic purposes. But some people could make this. But I'm going to untick milling because in my testing, I found that the milling and cutting options gave very unpredictable, unusable outcomes for this load case. So we're going to go for unrestricted. We'll click additive as well and die casting. So for die casting, we're going to untick Y and Z. So the ejection direction is X. And then I think that should be all we need. Click OK on that. For the materials, this is what material is going to be made out of. So we can go into Fusion's material library, go into metal. So by default, we've got aluminium selected. So we can put in an extra aluminium in there. We can scroll down. Let's put in aluminium 6061. To be fair, like it's not really, this is just playing around with it. We're not realistically going to make it out of these materials, so it doesn't really matter. We can go to magnesium. Where's magnesium at? There he is. There's magnesium. And then finally, all the way down at the bottom, we'll give titanium a blast as well. Okay, that's all the study materials done. We're now ready to execute the study. So what you want to do is save this so it doesn't bomb out or anything when you click go. The name should be BMW wheel tutorial. Make sure it's in your new project you created earlier on, and then click save on that. Okay, once that's saved, you can preview it if you want to, but you should. The results isn't anywhere near what the final outcome is going to be. There's also some warnings in the pre-checks, but that's just because it's got this cost estimation built into it, where it'll try and estimate how much it'll cost to actually make the generatively designed part. But the materials we've selected aren't supported by that algorithm, so we'll just leave that alone. And then select generate, and then you should see your account down in here, which you might be thinking, oh, I haven't got any cloud credits, but that's fine. It's fine. It's not going to cost you anything. See, required should say 0 or should have a dash. Click generate one study, and then that'll shoot off into the cloud and create all of the outcomes. Now, this might take a while. You might have to wait a couple of hours, a few hours, but once it gets going, I'll show you how to check up on it. Click close on this dialog box. You should see this pop up here. Thumbnails for your outcomes will appear once they are processing. Click OK on that. Click close on that. And then you should see your study in the left-hand side here. This is what it's now generating. And the rest of the options here are all of the filters. So it could give you sort of 30 to 50 to 100 different outcomes for generative design, all different variations of how you can manufacture this. And then you can filter them all out using these options here once the thumbnails have all been processed. So we'll pick this up once we've got something to work with. Okay, once you've got some thumbnails generated, there should be processing to the point where eventually you'll see the word either converged or completed underneath it. Converged means that it managed to hit the design objectives and create a part which satisfies the safety factor that you put in to the design constraints. If you see completed, if you hover the cursor over those, it'll say that it can't reach the objectives within the allowed iteration limit. The loads are probably too large or the material strength is insufficient. So you can go back to the study whilst it's free anyway, and then change the loads, lower the loads maybe, and then create a new generative study. And then you can see what it comes up with. So there's no guarantee that what you see will be the same as what I see. I've generated several different studies, all from the same model, just with different loads and whatnot. So pick one of the ones that you've found. For the purposes of just messing around with, it's fine to just pick one of the completed ones instead of one of the converged ones. It doesn't really matter for the purposes of what we're doing here. But if you were actually going to manufacture this, then yes, you'd need to go for one of the converged ones. So you can select one of the ones that's completed. Give the thumbnail a click. That'll take you into the preview environment where you can rotate it around and you can see. I mean, that looks absolutely stunning, doesn't it? That looks amazing. Well, so once you've got that done, you can select this button up here, create new design from outcome, and then you can select your generative design account and then create a new design. It'll shoot the model off into a Fusion 360 part for you to then further edit. We can then pattern it and do what we need to. So once we've got that exported, we'll pick this up later on. Okay, so in the job status window, if you've left that open, you should see, this is the one I was just exporting there. Once it's finished, you should see a little hyperlink. This is a clickable link to open design next to the one that you're exporting. You obviously won't have anywhere near as many jobs as I've got here, but click open design. It's got quite a few things to do in the background. Whilst you're telling it to do this, it's pulling data down from the cloud and then opening it up in the client. So it takes a few seconds to do these things, but it's actually quick given what it's actually doing. And then there you go, mate. Look at that. That's your generatively designed model brought across into the Fusion modeling environment. So there's a couple of extra things we need to do here before we convert this into the final model. It's chopped off the back end of the rim for whatever reason. So along the bottom of the Fusion 360, you've got this timeline here. So we're just going to right click on combine and then select delete feature and then go into the bodies and then turn off the obstacle body. For whatever reason, I don't know why, but it doesn't segment off this correctly. So we just need to do that extra step to get it to this point. Go to create, go to pattern, circular pattern, change the pattern type to bodies, select this full body, go to axis, give that a click, select the x-axis, and then for the quantity, put in 5, and then click OK. And then mate, look at that. Is that not just the most beautiful looking alloy wheel you've ever seen? That is I'm stunned by it, man. That's absolutely incredible. Okay, right. So we need to create a center cap for the middle of the wheel, which I mean we don't have to, but I'm going to anyway. But we'll click combine first. We'll combine all of these bodies together just so that it's one complete solid object. This is where Fusion starts to go, oh, you're doing too much. You're doing too much. There's a lot of data here to compute. So it starts to slow down a little bit. Depending on which computer you've got, it might start to chug away in a big way at this point. But select all the 5 tool bodies, make sure joins selected, and then click OK on that. There we go. That's all joined. I think we can delete the obstacle region. Right click on that body, click delete. Shouldn't break anything. Nope, no, we're good. We are good. Zoom out a little bit. We're going to create a new sketch. We're going to go through the plane here. Go into the sketch palette and then slice. And we're just going to create a revolve for the center cap. So we're going to scroll in and then we're going to... God, Fusion's really tanking now. It's really starting to struggle. We're going to project... Come on, you can do it. Project this edge here and then OK on that. Wow, this is really slow. It's really tanking. See if we can just make it to the end. Right, 3-point arc. We're going to draw an arc from... Come on, pick it up. There it is. There to about... This is really frustrating. Really frustrating. It's just so much lag. Look at this. Wow. Right, give that a click. And then we're going to pull the arc away. Oh my God, this is so frustrating. This is so frustrating. Give it another click about there. Right click. Come on, you can do it. Right click. Where's the menu? There it is. OK on that. And then we're going to go for a constraint, which I can't see. This one here. We're going to line that up to the center point. If that is selectable, it is. Okay, and then we're going to just close this region up with a line going from here to the center. Come on. Wow. To there. And then, is that continued the line it has? Right. And then we're going to close this region to here. That should give us a straight line going across there. Okay. Right. It's not that's not perfect, but it should do for the purposes of what I'm trying to achieve here. Right. So finish that sketch. And then we're just going to zoom out so we can see what we've just done. It's in the middle of here. So we're going to revolve this region, and then the axis is going to be its own little line there. And then we want to make sure we create that into a new body. Okay, that gives us, it's not the most prettiest thing in the world, but that gives us something to put the BMW sticker onto a little bit later on. Right, this next bit might fail disastrously, but we're going to give it a shot. So we're going to go into the panel, the Generative Design YouTube tutorial, and then we're going to import the tire. Come on, double click into that. Right, there we go. So there's our original file. So we'll file, open, and then we're going to go open from my computer, select the tire. And this is quite a heavy model. It's a mesh model, which I've converted into a Fusion Solid. So it's very detailed. I think there's hundreds of thousands of polygons potentially in this tire. So again, depending on which computer you've got, you might struggle big time here. All right, once the tire's opened, give that a save it into the YouTube tutorial project, and we'll just call this tire. That's all it needs to be. Give that a save, so that should appear in the panel on the left hand side when it's finished saving. Okay, we can close down the tire model, and then once we're back into the wheel that we've created, we haven't saved this yet, have we? So we need to click save on this, and then we can just call this the finished Gen Design wheel. Give that a save. So in the panel now, we've got the original Fusion model, which we created the generative design from. So this has got all the studies in. This is the output wheel that we've just patterned and then combined. And then this is the tire. So once it's finished with its little spinny circle of saving, we can grab the tire, just left click, drag that into this model. And it won't drop in exactly where it needs to be, but we can just move it ever so slightly. All right, so once that's in, we need to move it to the correct location. So you want to orbit around, select one of the faces of the cube so you're looking sort of side on, and then you can just grab the arrow, and then this is just approximate, you know what I mean? We're not actually creating a production model here, so roughly about there. Click OK, and then that's the tire. Kind of on the wheel. It looks okay. I mean, it looks okay. That's doing it a bit of an injustice. It looks absolutely magnificent, mate. Okay, we're going to save the model again, just so it doesn't crash out. And there you have it, mate. There you have it. There's your wheel with the tire on it. Now, for the render that I showed you in the thumbnail, I did that in Keyshot. So if you've got access to Keyshot, you can follow this bit along, or you can do a render in Fusion 360 if you want to. But I'm going to export this out as an FBX file to my desktop, and then bring that into Keyshot. So we're going to drop this down onto the desktop, finish Gen Design wheel, and then save, export. And then this might take a while. So yeah, I'm going to pick this up once it's finished the export. And there we go, it's all finished. And as you can see, mine failed the first time, which yours might, I don't know, but I had to run it again, the FBX output, and it's all done. You can show that in File Explorer. That should open up a link to your desktop. There it is. Right, so I'm going to hop on over to Keyshot, and then we're going to import the FBX into Keyshot. If you don't have Keyshot, like I said, you don't have to do this bit. You can use another rendering package of your choice. My normal go-to is Autodesk Vred, but just kind of putting things into perspective, I don't suppose much Fusion 360 users are actually using Vred. It's not really aligned with Fusion 360 in terms of price point. So here it comes in. I'm going to switch the rendering engine over to the GPU mode, which is new in Keyshot 9. It's really nice, actually. It's really good. And then we can start texturing this up. You're not going to do too much to it. Just put a carbon fiber texture on the actual wheel itself. Let's go to the tire material, drop that onto the tire itself. And then we're almost done. Maybe we'll go to the material for the roundel. Let's go for, I just want a standard old regular plastic. Nothing too fancy. Just hard, rough plastic white. That should do the job. I'll drop him onto that. Double click the roundel, edit the material graph. And then we need to open up our generative design folder with the roundel badge in. It's that one there. We're going to drop that into the graph, link that to the diffuse, and then I need to go to double click this material, textures, diffuse, planar. Okay, part. It's not quite right. Is UV going to work? Negative. So back to plane. There we go. It just seems to have fixed itself. That'll do me. And then for the tire, we can double click that, go to the material graph of the tire, again hop back on over to the Generative Design folder, drag the sidewall in. We can link that as the bump map, and that seems to have almost come in perfectly. I'm running out of screen real estate here, which is quite frustrating. But we can double click that material, go to textures, bump, and then I think we just need to scale it down a little bit, which will be width, possibly. Maybe. Drop that down to 78. That's close enough, isn't it? That's close enough. Scroll down for the bump height. You can either go for a normal map, or let's just go for a -1. That's fine. That's fine, mate. And there you go. Look at that. If you want to get creative, you can drop in some of these backgrounds. HDR. Oh, mate, that looks beautiful, doesn't it? Such a good rendering engine. Go over the camera. We can enable depth of field, focus distance, drop that on the center cap. There you go, mate. There's a generative design wheel brought into Keyshot. And it looks absolutely stunning. It really does look stunning. So hopping back on over to Fusion 360, if you jump back into the wheel tutorial F3D file, you can create new studies if you want to, and then just edit the loads. You can edit the manufacturing techniques, and you can do all this whilst it's free. Just trial and error, reduce the loads, and you might get a more defined, extensive array of webbing going on within the generative design part. Yeah, you might have to wait a couple of hours before these finish converging and completing, before you can start playing with them. But it's free, it's worth the wait, and that's how it's done. Okay, mate, there you go. So if you're watching this after December 31st, it is quite expensive to trial and error. So I highly recommend, if you are watching this within the free period, just play around with it as much as you can. Get to know the algorithm, get to know the engine, get to know the nuances of the generative design model, and then play with it as much as you can. Also, finally, massive thanks to Kenny Cornett, who helped me through this. He's a generative design consultant based in the States. He's been a massive help whilst I've been figuring all this out for myself. Came across a few issues, couldn't quite understand how the algorithm worked and what it was expecting of me, and he helped me through it. And this is his thing. He's massively into it. So thank you very much to Kenny, and thank you to you for watching this. Hope it was helpful. Good luck, and just have fun with this. It has all kinds of potential to get a head start on this kind of technology. Might do you good in the future. So there you go. Thank you very much. All the links are in the description to get going with this. Have fun. Cheers, man. Thanks a lot. See you in the next one. Toodles.